The woman who took this photograph never received credit for it. 2 men won the Nobel Prize using her work. She never knew. This is the complete story of Rosalind Franklin. Before we go into her story, I need to explain what DNA actually is. Because without understanding what was being discovered, you can't understand what was at stake. DNA, deoxyribonucleic acid, is the instruction manual inside every single cell in your body. It tells your body how to build itself, what color your eyes are, how your heart beats, everything. In the early 1950s, scientists knew DNA existed, but nobody knew what it looked like. Nobody knew its shape. And in science, if you don't know the shape of something, you can't understand how it works. You can't use it. You can't build on it. The race to find the shape of DNA was the most important scientific competition of the 20th century, and Rosalind Franklin was winning it. Rosalind Elsie Franklin was born on July 25, 1920, in Notting Hill, London. She came from a wealthy, educated Jewish family. Her father was a banker who believed strongly in education, but, like many men of his era, primarily for his sons. Rosalind was different from the start. At 6 years old, her aunt wrote in a letter that she was, and I am quoting directly, alarmingly clever. She decided she wanted to be a scientist at age 15. In 1938, the year before World War II began, her father tried to talk her out of it. He wanted her to do charity work instead. She didn't change her mind. She studied at Newnham College, Cambridge, one of only 2 Cambridge colleges that accepted women at the time. She graduated with a degree in chemistry in 1941, in the middle of World War II. She spent the war years researching coal at the British Coal Utilization Research Association. Her work helped improve the efficiency of gas masks for British soldiers. She published 5 scientific papers during the war. She was 23 years old. After the war, she went to Paris, where she learned X-ray crystallography at the Laboratoire Central des Services Chimiques de l'État, the technique that would define her career and eventually change the world. In Paris, she was happy. Her colleagues respected her. She was described by people who worked with her there as confident, precise, and exceptionally skilled. She did not want to leave. But in 1951, she was recruited back to England, to King's College London, to work on something new, something called DNA. Before we go further, I need to explain what X-ray crystallography actually is, because this technique is at the center of everything that follows. X-ray crystallography is a method for seeing things that are too small to see, even under the most powerful microscope. The way it works is this: you take a molecule, in this case, DNA, and you crystallize it. Then you fire X-rays at it. The X-rays bounce off the atoms in the molecule and create a pattern on photographic film behind it. That pattern, if you have the skill to read it, tells you the exact 3-dimensional shape of the molecule. It sounds straightforward. It is not. Getting a clear, readable X-ray image requires the sample to be prepared perfectly. The X-ray exposure has to be precisely calibrated. The angles have to be exactly right. And then reading the resulting image requires years of specialized training. Rosalind Franklin was extraordinarily good at it. Her images were described by other scientists as the clearest X-ray crystallography photographs of DNA that had ever been produced. That skill, that patience, that precision is what made everything else possible. In 1951, Franklin arrived at King's College London, and from the very first week, there was a problem, a misunderstanding about her role that nobody ever formally resolved, and that would shape everything that followed. Franklin had been offered the position with the understanding that she would be an independent researcher, in charge of her own X-ray diffraction work on DNA, her own project, her own results. Maurice Wilkins, a physicist who had already been working on DNA at King's College, believed Franklin had been hired to assist him, to support his existing work. A subordinate role. Nobody sat them down and clarified this. The head of department, John Randall, had written letters to both of them that were, at minimum, ambiguous. And so Franklin arrived at King's College believing she was leading her own research, and Wilkins believed she was there to help his. This was never formally resolved. and it poisoned their working relationship from the very first day. Wilkins later described their interactions as difficult. Franklin, by accounts from people who knew her, found the situation frustrating and professionally disrespectful. She responded the way she always had. She put her head down and focused on the work. Within months of arriving at King's College, she had significantly improved the X-ray equipment and techniques. Her images of DNA were already better than anything produced before. She was making progress faster than anyone expected. In May 1952, Rosalind Franklin and her graduate student Raymond Gosling set up their X-ray equipment and photographed a sample of DNA. The exposure took 60 hours. 60 continuous hours of X-rays directed at a precisely prepared DNA sample. The resulting image was cataloged simply as Photo 51, the 51st photograph in their series. When Franklin developed it and looked at it, she knew she was looking at something important. The image showed a clear X pattern at the center, surrounded by a series of precise dark bands. For someone trained in X-ray crystallography, that pattern meant one thing. The molecule was helical. It had a spiral shape. But Franklin was careful, as good scientists must be. The image was remarkable, but she wanted more data before drawing final conclusions. She knew that making a wrong announcement in science could damage a career permanently. She wanted to be certain. She kept working, kept refining, kept calculating. Photo 51 sat in her files. Documented. Cataloged. Hers. At the same time, at Cambridge University, 50 miles north of London, two men were also trying to find the structure of DNA. James Watson, an American molecular biologist, 23 years old. Francis Crick, a British physicist, 35 years old. They were not, at this point, succeeding. Their first attempt at building a physical model of DNA, in November 1951, was so fundamentally wrong that their supervisor Lawrence Bragg told them to stop working on DNA entirely and return to their assigned projects. They stopped. Officially. In November 1951, Franklin gave a seminar at King's College presenting her initial X-ray findings on DNA. Watson attended. He did not take notes. Later, in his memoir, he acknowledged that he could not remember the precise details of what Franklin had presented. Using his incomplete memory, he and Crick built another model. It was also wrong. Franklin pointed out the errors when she saw it. Their early attempts at finding the structure of DNA were failing. And then, in January 1953, everything changed. What happened in January 1953 is documented. Not disputed. Documented in Watson's own memoir, in historical accounts, and in the scientific literature. Maurice Wilkins showed James Watson Photo 51. Without Franklin's knowledge. Without her permission. Watson later described the moment in his memoir, The Double Helix, published in 1968, with unusual candor. He wrote that the instant he saw the photograph, his mouth fell open and his heart began to race. He wrote that the image was, in his words, far simpler than those obtained previously. He immediately recognized what it showed. The X pattern at the center. The helical structure. The answer. Watson went back to Cambridge. He told Crick what he had seen. They began building a new model. They also had access, through a Medical Research Council report, to some of Franklin's other unpublished data on DNA. Data that gave them specific measurements they needed. Franklin was not informed her data had been shared. She did not know Watson had seen Photo 51. She did not know any of this. She was still working in her laboratory at King's College, refining her results, preparing for a formal announcement that she wanted to make only when she was completely certain. In February 1953, Watson and Crick had their model. In April 1953, they submitted a paper to the journal Nature. The paper, Molecular Structure of Nucleic Acids, a structure for deoxyribose nucleic acid, described the double helix structure of DNA. It was published on April 25, 1953. It is one of the most important scientific papers ever written. In that same issue of Nature, Franklin and Gosling published their own paper, presenting their X-ray data, including their analysis of Photo 51. Their paper was listed as supporting evidence for Watson and Crick's model. Watson and Crick's paper acknowledged that they had been stimulated by a knowledge of the general nature of the unpublished experimental results and ideas of Franklin and Wilkins. One sentence, buried in the paper. Photo 5.1 was not mentioned by name. Franklin was not directly credited for the X-ray work that made the model possible. In 1953, the same year the DNA papers were published, Franklin left King's College. She moved to Birkbeck College, London, where she joined the laboratory of crystallographer John Desmond Bernal. By all accounts from her colleagues at Birkbeck, she was significantly happier there. The working environment was different. She was respected. She did extraordinary work on the tobacco mosaic virus, producing some of the most detailed X-ray crystallography images of a virus that had ever been made. Her work at Birkbeck contributed substantially to understanding how viruses are structured. She was, by any measure, one of the leading X-ray crystallographers in the world. In the summer of 1956, she became ill. She was diagnosed with ovarian cancer. She was 36 years old. Many historians and scientists have noted that her years of close work with X-ray equipment, particularly during the intensive periods of photographing DNA at King's College, likely contributed to her cancer. X-ray radiation was not as carefully controlled in the early 1950s as it is today. Franklin reportedly did not always wear protective equipment when working with the X-ray machines. She continued working through her illness. She published papers during her treatment. She traveled to the United States on scientific visits. She continued running her laboratory. Most of her colleagues did not know she was sick. Rosalind Franklin died on April 16, 1958. She was 37 years old. The cause of death was ovarian cancer. She is buried in Willesden United Synagogue Cemetery in London. Her gravestone reads, "Her research and discoveries on viruses remain of lasting benefit to mankind." For years after Rosalind Franklin's death, in October 1962, the Nobel Prize in Physiology or Medicine was awarded to James Watson, Francis Crick, and Maurice Wilkins. The prize was awarded for the discovery of the molecular structure of DNA and its significance for information transfer in living material. The Nobel Prize cannot be awarded posthumously. This rule was formally codified in 1974, but it was the practice before that as well. Franklin could not have been nominated even if the committee had wanted to include her. The timing meant she was permanently ineligible. In Watson's Nobel acceptance speech, Rosalind Franklin was not mentioned. In Crick's Nobel acceptance speech, Rosalind Franklin was not mentioned. In Wilkins' Nobel acceptance speech, he mentioned Franklin once. He described her as a colleague who had made valuable contributions. In Watson's 1968 memoir, The Double Helix, he wrote about Franklin in terms that many scientists and historians found demeaning and dismissive. He described her physical appearance. He questioned her scientific judgment. He portrayed her as an obstacle. The scientific community responded sharply. Many colleagues defended Franklin publicly. In later years, and this is documented, Watson expressed regret about how he had portrayed Franklin in the memoir. He acknowledged that photo 51 had been crucial. He acknowledged that Franklin's contribution had not been recognized as it deserved. But by then, the Nobel Prize had been awarded. By then, Franklin had been dead for decades. The historical record on Rosalind Franklin raises questions that scientists and historians have been debating since the 1970s. Let me be precise about what is documented and what remains disputed. What is documented? Photo 51 was shown to Watson by Wilkins without Franklin's knowledge or permission. Watson confirmed this in his memoir. Watson's access to the MRC report containing Franklin's unpublished measurements was a factor in Watson and Crick's model building. This is documented in historical accounts and acknowledged in subsequent academic work on the subject. Watson and Crick's published paper did not explicitly credit Franklin's X-ray work as the source of key evidence for their model. Franklin was not informed about any of this before the papers were published. What is disputed? Whether Wilkins acted with intent to undermine Franklin, or whether he genuinely did not understand the significance of what he was doing. Whether Watson and Crick fully understood, at the time, how much their model depended on Franklin's specific data, or whether they believed their own theoretical work was the primary driver. Whether the scientific norms of the early 1950s made what happened more understandable, even if not acceptable by today's standards. These are genuine disputes among serious historians of science. I present them as disputes, not with a conclusion already decided. What is not disputed, photo 51 was Rosalind Franklin's. She took it. She produced it. It was shared without her knowledge. And the people who used it won the Nobel Prize. She did not. Here is what I want you to take from Rosalind Franklin's story. Not that Watson and Crick were simply villains. History is rarely that clean. Watson and Crick made a genuine, significant scientific discovery. The double helix is real. Their model was correct. Their contribution to science was real. Not that science in the 1950s was uniquely corrupt. What happened to Franklin, the dismissal of her work, the sharing of her data without her knowledge, the failure to credit her appropriately, was not unusual for how women scientists were treated at the time. It was, in many ways, the norm. What I want you to take from this is something simpler and more specific. Rosalind Franklin did extraordinary work. She did it precisely. She did it carefully. She did it without seeking attention or glory. She sought only to get the answer right. Photo 51. 60 hours of exposure. The clearest X-ray image of DNA ever produced at that time. An image that showed, unmistakably, that DNA is a double helix. She took it. That is a fact in the historical record. That will never change. The world she worked in did not give her the recognition she deserved in her lifetime. The system she worked within, in science, in academia, in British institutions of the 1950s, did not value her contribution equally. But the photograph exists. The data exists. Her papers exist in the King's College Archive and at the National Archives. And every time someone talks about the discovery of DNA structure, Rosalind Franklin's name belongs in that conversation. Not as a footnote, not as a supporting character, as one of the central figures in one of the most important scientific discoveries in human history. She did the work. The record shows it. That will never change. This channel exists to tell stories like these in their entirety, not condensed versions meant to fit into a single paragraph, nor versions edited merely for convenience or practicality. We present the full version, including details previously left out, all based on documented records. If you find value in this video, please subscribe, as future stories on this channel follow the same principle. Everyone in these stories deserves to have their tale told in full. That is the mission of this channel. New videos are released every week. See you there.